Michaelnagar Shikshaniketan Higher Secondary Government-sponsored co-ed English medium school has taken an excellent initiative of teaching and make our students learn day-to-day lessons through audio and video in our YouTube channel. Teachers of all the subjects are working hard to enhance these online classes in the midst of this pandemic situation. It is a request to all the teachers, students and guardians to click the bell icon and subscribe our channel.
Hello students, I am going to start unit 8.3 from class 10 syllabus, that is electricity and chemical reactions. Okay. So at the beginning of the chapter we have to learn some terms related to this chapter, and I am starting here those one by one. Okay. So the first term is conductors. What are conductors? The substance or the materials, those who allow to pass the current or electricity through them, they are known as the conductors. Okay, example of conductors are metals and electrolytes. As we know that all the metals are can conduct electricity, and all the electrolytes can conduct electricity through the ions. Next is non-conductors. Those who don't allow to pass electricity through them, they are known as non-conductors. All the insulators, that means like paper, like rubber, like glass, they act as the insulators, and all the non-electrolytes act as the non-conductors. Next point is electrolytes. Okay, electrolytes means the substance or the material that in molten state or in solution state can conduct electricity, producing ions. That means all the acids, bases and salt solution, they can produce ions, and through the ion they can conduct electricity. Okay, but obviously we have to mention the point in molten state or in solution state. So they are known as electrolytes. Next point is non-electrolytes. That means in molten state or in solution state, those who can't conduct electricity, actually they can't produce ions, so that's why they can't conduct electricity. They are known as non-electrolytes. Sugar solution, benzene, kerosene, they can't produce ions actually, so that's why they can't conduct electricity. Now the next point is ionization. What is ionization? Actually these electrolytes, these conductors, all they can conduct electricity producing ions. Here I have mentioned a molecule of a generally obtained compound like AB. If we consider such molecule AB, it will produce one positively charged ion, that is known as cation, that is A plus, and one negatively charged ion which is known as anion. So through this cation and anion they can conduct this electricity, and the process, that is by which process this this whole molecule is splitting into the ions is known as the ionization. That means ionization or dissociation is the process through which a whole molecule of an electrolyte is splitting and producing a positively charged ion and a negatively charged ion, is known as the ionization. Okay. The next thing is we can classify electrolytes into strong electrolyte and weak electrolyte. Strong electrolyte means the electrolyte those who can dissociate completely. That means if we take 1 mole of HCl or 1 mole of H2SO4, we can get 1 mole of H plus ion and 1 mole of chloride ion, or in case of sulfuric acid, it will produce 2 moles of H plus ion because there are 2 hydrogen atoms, and 1 mole of sulfate ion. So these are known as strong electrolyte. We can also consider sodium chloride or nitric acid as the example of strong electrolyte. The next is weak electrolyte. That means those who can't dissociate completely. That is why I am giving here the equilibrium sign. Here I have given the one directional sign, that means it can dissociate completely, but it can't dissociate completely, so I have given a equilibrium sign. Ammonium hydroxide, acetic acid, carbonic acid, these are the examples of weak electrolyte. Ammonium hydroxide can produce ammonium ion and hydroxide anion. Here acetic acid can produce the H plus ion and the acetate ion, and the carbonic acid can produce 2 H plus ions and 1 carbonate ions. Okay, but all of them are known as weak electrolyte. Okay, the next thing is electrolysis. Electrolysis means it is the process through which we have to pass the electricity and chemical changes will happen. Okay, here I have drawn a picture of normal electrolysis process, where the process is carried out in the place is known as voltmeter, and in the voltmeter, within the voltmeter we have to take the electrolyte solution. It will be in molten state or in solution state. Okay, and within this electrolyte, that is within the solution, we have to dip generally 2 metal strips. Okay, and these 2 strips are connected with the 2 terminals of a battery. The negative terminal is connected to a strip which is known as the cathode, and the positive terminal is connected to the strip is known as the anode, and together they are known as electrode. Okay, so in the process electrolysis, here electric energy will convert it to the chemical energy, and we require here a voltmeter, an electrolyte solution in solution state or in molten state. We need 2 metal strips, those who are known as the electrode. One will be cathode, which will be connected to the negative terminal of the battery. One will be anode, which will be connected to the positive terminal of the battery. And if we allow to pass the electricity now, this electrolyte will dissociate, forming one cation and one anion. Suppose if we take here NaCl as the electrolyte, obviously it will be in solution state or in molten state, so it will dissociate and it will form Na plus and Cl minus. Okay, Na plus is the cation, Cl minus is the anion, so NaCl will produce sodium plus and chloride ion. Now according to the rule, we know that all the cation will move towards the cathode, because cathode is connected to the negative terminal of the battery, so it will act as the negative pillar. Okay, negative charged pillar. So all the cations will move towards this cathode. So all the Na plus ion will move towards this cathode. So in the cathode, it will be as Na plus will accept 1 electron, as there is 1 positive charge, so it will accept 1 electron and it will form sodium in neutral state, that is in normal solid metallic state. Okay, and all the anions will move towards the anode, because this strip is connected through the positive terminal of the battery. That is why we can consider it as the positive charged pillar. So all the anions will move towards the anode. Okay, and Cl minus will move towards the anode and will remove 1 electron, as there is 1 negative charge, so 1 electron will be removed and it will form chlorine, just chlorine atom. Okay, so in this way we can get 2 chlorine atoms combining chlorine molecule, and this chlorine gas will be removed from the anode. Okay, and here I have written reduction. In case of cathode reaction, as we can see that acceptance of electron is occurring here actually, so that is why the process is reduction. Okay, and in anode, electron is removed from the ion, so this process is known as oxidation. Okay, so this is the common phenomena for cathode, that is reduction, and oxidation is the common phenomena for the anode. So I am repeating again the whole thing, That is, we need a voltmeter where we have to take the electrolyte solution which will be in solution state or in molten state. If we consider sodium chloride solution as our example, so it will produce sodium plus ion and chloride ion, and this sodium plus will go towards the cathode, and going towards the cathode it will accept one electron and it will produce sodium metal, and all the anion, that means the chloride ions, will go to the anode, and going to anode it will form chlorine chlorine atom, and in this way we can get more than one chlorine atom which will combine and will produce chlorine gas. The process which is occurring at the cathode is known as reduction, because here acceptance of electron is occurring, and the process which is happening at the anode is known as the oxidation, because removal of the electrons. Okay, next, according to our syllabus, we have to study the electrolysis of water and the electrolysis of copper sulfate solution using copper electrodes. Okay, so first I am starting the electrolysis of water. So for electrolysis of water, we have to take acidified water in the voltmeter. As we know that water is not a good conductor of electricity, so we have to add any electrolyte within the water. So if I add any salt solution, or I can add any acid or base which can act as the electrolyte, we can add within the water. So as the electrolyte I have written acidified water here. Okay, and then we have to take two electrodes which will be act as the anode and the cathode, and here for this process I have taken platinum electrodes. Okay, platinum electrodes will be acted as the anode and the cathode both. So the water, now if I pass the electricity, the water will dissociate and it will produce the hydroxylium ion, that is H plus ion, and hydroxide ion, that is OH minus ion. Okay, and as we know from the previous dissociation of NaCl, that all the cations will move towards the cathode. So all the H plus ions will move towards the cathode and will consume one electron, as hydrogen is monopositive. That means hydrogen has one plus charge on it. So it will consume one electron and it will produce hydrogen atom. So two hydrogen atoms will be combined in the next step and it will produce hydrogen gas. And this hydrogen gas, if we can arrange the system properly, we can control the flow of hydrogen gas. And next thing is the hydroxide ions, that all the OH minus ion, they will move towards the anode. Okay, and in the anode oxidation takes place, as we know. So it will reject one electron and will produce hydroxyl as a functional group. Okay, so in this way 4 functional group will combine and it can produce 2 molecules of water and 1 molecule of oxygen gas. So if we cover the whole process, the whole reaction, we can see that 2 molecules of water will produce 2 molecules of hydrogen gas and 1 molecule of oxygen gas. If we see the formula of water, that is H2O, we can see that there are 2 hydrogen atoms and 1 oxygen atom. So that's why the ratio of hydrogen and oxygen is 2:1. In the process, that is electrolysis of water, the production of hydrogen and oxygen is also maintaining the same thing, that is hydrogen in 2 parts and oxygen in 1 part. That is hydrogen is to oxygen will be 2:1. Okay, this is the electrolysis of water. I am repeating again the process. According to the rule, we have to take acidified water, as pure water is not a good conductor of electricity. So that's why we have to add the acid. According to the previous thing, we have to take electrodes there, and we have taken platinum electrodes as the cathode and anode. Then water will dissociate, producing H plus ion and OH minus ion. all the cations, that means all the H plus ion will move towards the cathode, and they will accept 1 electrons, that means 1 electron for each of the H plus ion, and it will produce H atom. Then 2 H atom can combine to produce hydrogen gas, and all the hydroxyl ion will move towards the anode. It will reject 1 electron, producing the functional hydroxyl group. 4 functional group can combine and they can produce water and oxygen, and overall process is 2H2O is equal to 2H2 and O2, 2:1 ratio maintaining. Okay. So next process is the electrolysis of copper sulfate solution using copper electrode. In the previous process we have used platinum electrode, but here we are using copper electrode. That means the process will be changed from the previous one, because the reaction is changing here. Okay. First, the electrolyte will be the aqueous solution of copper sulfate. That means in solution there will be copper sulfate to dissociate and as well as water molecule to dissociate. So from copper sulfate we can get copper 2+ ion and sulfate ions, and from water molecules we will get H+ ion and OH- ion. So we have here 2 types of cations, okay, for the cathode, but from H+ and Cu2+, Cu2+ will move towards the cathode because hydrogen ion is more electropositive. H+ ion is more electropositive with respect to the copper ion Cu2+. So that's why H+ will not move towards the cathode. Cu2+ ultimately will move towards the cathode, and it will consume 2 electrons because copper is divalent. Okay, copper has 2 positive charges, so that's why it will consume 2 electrons, producing copper metal, and this copper metal will deposit over the cathode. So ultimately at the finishing of the process we can see that the weight of the cathode has been increased due to deposition of the copper metal. And in the previous one we have seen that the anions have moved towards the anode. So we have sulfate anion and hydroxyl anion here, but none of them will move towards the anode here, because the potential value, that is the ionization potential value of copper 2+ is less with respect to the discharge potential value of sulfate ion and hydroxyl ion. So we have taken copper as the electrode. So as cathode and as anode we have taken both the copper electrodes. So from the anode the copper metal will lose 2 electrons forming Cu2+. Okay, none of the anions will move here towards the anode. The copper metal itself will lose 2 electrons producing Cu2+ ion, and this Cu2+ ion will maintain the copper 2+ concentration in the copper sulfate solution. Okay, so finally we can say this Cu2+ solution will go into the solution, and that Cu2+ will move to the cathode accepting 2 electrons. It will form copper metal. So finally we can see the weight of the anode is decreasing and the weight of the cathode is increasing due to the deposition of the copper metal. After we have done the related terms of this chapter, and we have done the electrolysis of sodium chloride, electrolysis of water, and electrolysis of copper sulfate solution using the copper electrode. Okay. Next we have the application of the electrolysis, which you will get in the next video.
Thanks for watching. Leave a like and comment. Subscribe. And do share the video among your friends.